Today class we're going to go over chapter 5, which is polynomial functions. Last chapter we went over was on quadratic functions. But necessarily today we're going to be talking about properties of exponents. Pretty much at the end of the lesson you're going to be able to simplify expressions of all powers, which is the same thing as exponents. And we're also going to be talking about scientific notation, okay, how to write numbers in scientific notation. Let's talk about scientific notation. If you guys forgot or haven't dealt with scientific notation, I'm pretty sure you have in your chemistry class. Scientific notation, it just means that number C, okay, and C, there's something that has to be important about C. C has to be between 1 and 10. Okay? C could be equal to 1, but C cannot be equal to 10. That's what the inequality means there. So pretty much C has to be between 1 and 9. Okay? Anything above 9, you have to actually change it down so that it is between 1 and 9. And n is just an integer. Okay? Some properties of exponents. These are all the important properties. If I'm forgetting any, just remind me, but I think I hit most of them. Just pay attention. If the base is the same, this is what this is saying. If the base is the same and we're multiplying, therefore we add the exponent. So that's why we have base is a, we add m plus n, and whatever the result is, make sure that it's in simplest form. Again, we don't like to have negatives. I give you a property for a negative. If you have a negative exponent, just put it under 1, and that's how we want to see our answer. The opposite of multiplication is dividing. Over here, if we're dividing something with the same base, okay, we're going to go ahead and subtract the exponents. But again, we're going to practice. I have about 12 examples that we're going to go over, practicing exponents and scientific notation. Alright, so let's go ahead and do 2 examples. Again, I'm going to do 2 examples. Okay, if you're confused, if I'm going too fast, just go ahead. And you're going to have time to practice on examples 2 and 3. I'm going to do 1 and 4 for you. Alright, let's go to begin. Alright, so if we notice problem number 1, our base is 5, okay? So we're multiplying 5 to the 0, 5 to the power of 5, 5 to the power of negative 3, okay? So since they're all the same base, we have base of, let's take them individually. We know that this right here, anything to the power of 0 is going to be 1, so I'm going to actually change that into 1. 5 to the power of 5 stays the same. And 5 to the power of negative 3 actually becomes 1 over 5 to the power of 3. So this is just one of the many ways you could solve this. Okay. Let's go ahead and multiply across. 1 times 5 to the 5th times 1 is 5 to the 5th. And 5 to the 3rd stays on the bottom. We still have the same base. And if you look at your properties of exponents, okay, this becomes 5 minus 3, which is the same thing as 5 squared. And again, if this number is above, let's say 8, just leave it as 5 to the 8th power, okay? But since it's below, we actually know what 5 squared is, which is 25. And again, the reason we're going over exponents is because we're going to see it all in this chapter. Okay. All right. So our answer is 25. Okay. There's a different way to solve it. Okay. I'm going to leave that up to you for your homework. Try to solve this problem using a different way. And tomorrow, when you guys come to class, that will be one of the questions that I'm going to ask you. Okay. I'm going to ask for a volunteer to come up, solve number 1 differently than Mr. Mira. Okay. All right. Next, let's go ahead and do number 4. 4, I have 1/3 is my base, okay? And that is being raised to the -2, and I'm multiplying the entire thing by 3, okay? So what I'm gonna do is I'm actually gonna multiply the 3 to the -2, which is gonna give me 1/3 to the -6. Okay? Alright, so you could actually distribute the -6 to both powers, okay, or to both numbers, or you could actually change this into positive simply by flipping the inside. Okay? Since I flipped, the reciprocal of 1/3 is 3/1. Since you flipped it, you're actually doing the opposite of a negative. Okay, that's what it says. You put this entire thing over 1. Now distribute the 6. We get 3 to the 6, 1 to the 6. Okay. 3 to the 6 divided by 1 to the 6 is the same thing as 3 to the 6. Okay. So again, since this number is below 8, you're going to multiply 3 6 times. So in essence, you're multiplying 27 times 27, which is 729. Okay. And again, there's multiple ways to solve this. Again, as a participation for tomorrow's class, I'm going to ask someone to solve problem number 4, doing it differently than Mr. Mira. Okay. So let's go ahead and get back to our lesson. Alright, so I solved number 1 up here, we got 25. Number 4 over there, we got 729. So for homework, I want you to do 2 and 3. So as you're watching this lesson, please stop it. Try to do 2 and 3 before you actually move on, or you can watch the entire thing and then come back. But make sure you do 2 and 3. Okay. All right. Next, let's go ahead and go over scientific notation. Okay. I'm gonna go ahead and do number 5 for us. I'm going to erase the board over here. We have 3.2 times 10 to the 4th, 1.5 times 10 to the 5th. Okay. So again, what's unique about scientific notation, you could actually multiply this number in your calculator. You're going to get 3.2, 1, 2, 3, 4. This 4 means you move 4 to the right. All these placeholders become 0. So 3.2 times 10 to the 4th gives us 32,000, okay? And then 1.5 times 10 to the 5th, 1, 2, 3, 4, 5. Again, all these placeholders, we get 0. This is actually 150,000. So you could actually multiply those two numbers and then change it into scientific notation, or I'm going to show you a shortcut. You could multiply the numbers together, 3.2 times 1.5 will give you 4.8, okay? And then, if you look here, we have same bases. We have 10 to the 4th, 10 to the 5th. We could add those exponents, since the base is the same and we're multiplying. So 10 to the 4th times 10 to the 5th is actually 10 to the 9th. Okay? So if you put this together, our answer is 4.8 times 10 to the 9th, which is the same thing that you get when you multiply these two numbers together. Okay? And you change it back into scientific notation. So let's go ahead and run through the definition of scientific notation. My number is between 1 and 10, okay? And, okay, so it's 4.8, which is between 1 and 10. And this is in scientific notation because it has times 10 to some power. All right, let's go ahead and try a tricky one. Let's go ahead and try number 7, which is negative. go ahead and turn my slides off. So I have 5.7 times 10 to the negative 6 times 6.2 times 10 to the positive 8. Okay. Again, you could multiply these numbers out and then use your calculator and then work backwards to change it into scientific notation. Or you could simply just multiply 5.7 times 6.2, which is going to give you 35.34. Okay? Then you take your powers, 10 to the negative 6 times 10 to the 8 gives you 10, negative 6 plus 8, since we're multiplying, and that's going to give you 10 squared. Okay? Now, you put those two things together, we're going to get 35.34 times 10 squared. Okay? Now, if you were paying attention, okay, we know that this is a mistake. Okay? We cannot leave our answer like this because 35 is not between 1 and 10. So, Mr. Mira, like he always wants to trick you, was testing if you were paying attention. So, what you have to do, let's move this over to the left. And since we're moving it over to the left, we're actually making this number bigger. Okay? So this becomes 3.534 times 10 cubed. And that right there is scientific notation, exponents. Okay. I'm going to go ahead and show you the last slide. All right, so here's 4 more examples. Okay, these are a bit challenging, but I'm going to have you practice them. Again, these are just a little bit more challenging than the first 4 problems, but I'm pretty sure you could handle it. Make sure to practice these at home. Again, be ready to come prepared with questions. If you're struggling with one of these examples, you let me know, and that's the first thing we'll tackle when we come back tomorrow. Okay? Stay tuned for the next lesson. We're going to be covering graphing polynomial functions. Thank you, guys. Homework. All right, so in your textbook, focus on 3 to 35, all the problems.